Hello students, how are you? You might be enjoying our lectures. This is our third lecture and today we are going to discuss about isothermal and three other thermodynamic processes. Now let's see. What are thermodynamic processes? Thermodynamic process. Today we are going to discuss various types of thermodynamic processes. Four of these thermodynamic processes. Actually, thermodynamic processes are those which are related to certain thermodynamic variables such as pressure, volume, temperature. Here we are going to discuss one of them exhaustively. Okay, now first isothermal process. Isothermal process. It is that thermodynamic process in which temperature of the system remains constant. That means whatever be the condition means your system is expanding or system under compression, then whatsoever be the condition, your temperature is not going to change. Temperature will remain same, that is constant. So that thermodynamic process is known as isothermal process. Second one, isobaric. Third one, isochoric. And the last one, adiabatic. In the first process, as we have defined, that your temperature T is going to be constant. Similar way, in isobaric, the other thermodynamic variable, which is pressure here, that is going to be constant. In isochoric, volume is going to be constant. And the last one, which is one of the most important thermodynamic process, in that the system is not going to have any change in its total energy. That means the energy of the system is not going to be transferred to the surrounding, and not the system is accepting any energy from the surrounding, that the total energy of that system is going to be constant. Now we are going to have an exhaustive explanation of the isothermal process. Let's look at this. Isothermal process, we have seen that the temperature of the system should remain constant. Now consider a system containing a gas filled in a container provided with a frictionless piston which is moving inward or outwards without causing an increase or decrease in temperature due to its friction. Now, this is your piston. This is the container. Now, the walls of the container, first condition for maintaining an isothermal or a constant temperature of this system, your walls should be of the container, they should be conducting. They should be conducting. And the other word that we use for such type of walls, that is diathermic. Diathermic means those walls which accept the transfer of temperature or heat through it. Number two, when this piston is moving inwards and the gas which is filled here in the container is going to compress. This causes the increase in temperature of the gas due to compression. As we have seen, these walls, they are conducting diathermic, so the heat which is produced due to compression, that will easily be passed on to the surrounding. Heat will be passed on to the surrounding. So first condition is the process of compression should be so much slow that it can give a lot of time to the transfer of heat produced due to it to the surrounding, so as the temperature of the system remains constant. Similarly, when it is going to move out, your piston is moving upwards. The second condition, in that way, your gas is going to expand, and that needs an external energy, means the temperature of gas is going to fall. But due to the diathermic or conducting walls, the system, that is gas, that will absorb the heat from the surrounding and will maintain a constant value of temperature. So the second condition for the isothermal process is that the process of compression and expansion should be slow. Why slow? So that the transfer of heat from system to surrounding and vice versa can easily take place. That is how your system is going to be an isothermal process. Now, in our next step, we are going to explain how the isothermal process can easily be described with the help of your first law of thermodynamics. Now, what is the statement actually of the first law of thermodynamics? First law of thermodynamics says that when some heat is given to the system, some heat is given to a body, that is going to be utilized in two ways. Which are those ways? Number one, the heat given to the system, if we are going to consider it as delta Q, Q is the heat, then it is going to be utilized in two ways. One is to change its internal energy. Here, U is the internal energy, and the other part of the heat which is remaining here, it is going to do certain amount of work done. And later on, we can even say this expression for work done can be written as P delta V, where V is the volume and P is the value of the constant pressure here. But if your temperature is going to be constant, for constant temperature, the internal energy is not going to change. That means the change in internal energy, that is going to be zero. Internal energy is zero, so your heat change now will only be having an expression of P delta V. This delta V is the change in volume. It can be positive during expansion and can be negative during compression. So when compression is going to take place, your volume, that is going to change, and the heat is going to be transferred to the surrounding. Similar way, when expansion is going to take place, volume is going to be increased, so heat is going to be absorbed by the system from the surrounding. This is how your first law of thermodynamics is giving the transfer of heat to the surrounding and the absorption of heat from the surrounding. I think you might be well clear about all these facts that we have studied about isothermal process. In the similar way, your isochoric volume is going to be constant. So in this expression, only this delta V, that is going to be 0, and delta Q would remain only delta U. In the similar other ways, in isobaric, pressure is going to be constant, so there is not going to be any change in your expressions. Okay, if you're going to have any other questions, you can have your feedback. You can even comment on my channel, Physics Classes by Dr. Dushyant, on YouTube. You can also follow me on my Facebook page, that is with the same title, Physics Classes by Dr. Dushyant. Have a nice time and enjoy your lecture, and be with me through this course of physics for 11th as well as 12th. Have a great time ahead. Thank you.